There is a lamp that runs on salt water. No battery, no electricity, no solar panel, no fuel. You fill it with 2 tablespoons of kitchen salt and 1 glass of water. It lights up, 8 hours, continuously. The technology behind it is called a galvanic cell, the same reaction that powers every battery ever manufactured. It has been understood since In 2015, a Filipino engineer named Aisa Mijeno built a working version that costs $3 to assemble. She demonstrated it publicly. She won international awards. 730 million people on this planet still have no electricity. They burn kerosene every night. A fuel that gives them lung cancer, burns down their homes, and costs them up to 30% of their annual income. The lamp that could replace it sits in a glass of salt water. The lighting industry is worth over $140 billion a year. And somehow, right now, you are hearing about this for the first time. In this video, let us start with what is actually happening inside that glass. Because the phrase saltwater powers a lamp sounds like something from a conspiracy forum. And if you leave it at that, you deserve to be skeptical. So here is the real science. Slowly, clearly, no jargon, the lamp is not powered by salt. It is not powered by water. Those 2 ingredients are important, but they are not the source of energy. The source of energy is a metal, a small strip of magnesium, about the size of your index finger. Magnesium is the 8th most abundant element in the crust of the Earth. It makes up roughly 2% of everything beneath your feet right now. It is in your bones. It is in spinach. It is dissolved in every drop of ocean water on the planet. According to the United States Geological Survey, it is the 3rd most plentiful element in seawater. It is not rare. It is not expensive. It is everywhere. Inside the lamp, there are 2 electrodes. One is that magnesium strip. The other is a carbon rod. Between them, you pour the salt water. When salt dissolves in water, it breaks apart into sodium ions and chloride ions. These charged particles allow electrons to flow from the magnesium through an external circuit to the carbon. That flow of electrons is electricity, pure and simple. On the carbon side, oxygen from the surrounding air participates in a second reaction, completing the circuit. The technical name for this is a metal-air battery. This is not a new idea. This is not even a modern idea. In 1800, an Italian physicist named Alessandro Volta stacked alternating discs of zinc and copper with pieces of cloth soaked in salt water layered between them. He called it a voltaic pile. It produced a small, steady electrical current. It was the first battery in recorded history. The unit of electrical potential, the volt, is named after him. 36 years later, British chemist John Frederick Daniell improved the design by separating the 2 metals into distinct chambers connected by a salt bridge. The Daniell cell provided a more stable and longer-lasting current. It became the foundation for telegraph systems across Europe. And if you want to go even further back, consider what archaeologists found near Baghdad in 1936, a small clay jar from the Parthian period dated to somewhere between 150 BC and 223 AD. Inside was a copper cylinder containing an iron rod, sealed with an asphalt plug. When researchers filled replicas with vinegar or grape juice, the device produced approximately 1.1 volts, enough to generate a visible spark. It is known as the Baghdad battery. Its purpose is still debated, but the chemistry is identical. 2 different metals, a liquid electrolyte, electron flow. 2,000 years ago, someone understood this principle. 226 years ago, Volta formalized it. 190 years ago, Daniell refined it. And in 2015, Aisa Mijeno put it inside a lamp designed for families who have never had electric light. Mijeno is a Filipino engineer and faculty member at De La Salle University. She grew up aware that thousands of island communities across the Philippines, a nation of over 7,000 islands, have no connection to the electrical grid. After Typhoon Odette struck in 2021, over 1.7 million electricity customers lost power. In several provinces, full restoration took more than 2 months. Typhoons are not rare events. They are annual certainties, and every time one hits, the grid collapses. Communities revert to kerosene. Mijeno designed the SALT lamp, which stands for Sustainable Alternative Lighting. The device uses a magnesium alloy anode and a carbon-based cathode. You pour 2 tablespoons of ordinary table salt and 1 glass of water into the reservoir. The salt dissolves. The circuit closes. The LED switches on. It runs for approximately 8 hours on a single fill. When the magnesium anode eventually corrodes, which takes roughly 6 months of regular use, you replace it. A replacement strip costs less than $1. The carbon cathode lasts essentially indefinitely. The LED itself is rated for 50,000 hours, total build cost under $3. Recurring cost $1 every 6 months. Operating fuel, salt and water. That is the technology. Mijeno presented it at the Asia-Pacific Economic Conference in 2015, where she shared a stage with the President of the United States and the founder of Alibaba. She won the Philippines People's Choice Award at the World Startup Competition. She received the 10 Outstanding Young Men Award in 2019. Germany's Federal Ministry of Education and Research gave her the Green Talents Award. She was recognized with the Good Design Award in 2018. She was applauded, celebrated, photographed, and then the world moved on. Now, let us talk about why that matters, and let us use numbers, because numbers do not lie. According to the International Energy Agency, 730 million people worldwide lacked access to electricity in 2024. That decline was only 11 million from the previous year. The pace is slower than pre-pandemic progress. 85% of the global unelectrified population lives in sub-Saharan Africa. The IEA's preliminary 2025 data suggests this trend will continue. These families do not sit in darkness every night by choice. Most of them burn kerosene. And kerosene is a disaster, dressed as a solution. The World Bank estimates that the world's poorest citizens collectively spend $38 billion per year on kerosene fuel. For many families, that represents 20 to 30% of their household income. 30% of everything they earn spent on a bottle of liquid that produces roughly 1/10 of a lumen per watt. For comparison, a standard LED produces 75 to 110 lumens per watt. A kerosene wick lamp is approximately 1,000 times less efficient at producing visible light than the cheapest LED on the market. But efficiency is the least of the problems. According to the World Health Organization, 2.9 million people die prematurely every year from illnesses caused by household air pollution. A significant share of that pollution comes from burning kerosene indoors. A study published in Environmental Science and Technology found that kerosene wick lamps convert 7 to 9% of their fuel directly into black carbon. Black carbon is the second largest contributor to global warming after carbon dioxide. For context, a diesel engine converts approximately 0.001% of its fuel into black carbon. A single kerosene lamp per unit of fuel burned is thousands of times dirtier than a diesel truck. Research published in the journal PLOS found that only 27.6% of homes using open-wick kerosene lamps met the World Health Organization's indoor air quality guidelines. Compare that to 75% of homes using solar-powered lighting, and then there are the fires, the burns, the poisonings. The WHO's systematic review concluded that household kerosene use is a significant cause of burns and child poisonings globally. Tipped lamps, spilled fuel, children mistaking kerosene for water. After Typhoon Odette in the Philippines, communities without power relied on kerosene lamps for weeks. House fires followed. A study covering for African countries documented the frequency of kerosene-related accidents across over 3,000 non-electrified households. The results were, in the researchers' own words, cause for concern. These families are not just unserved by the lighting industry, they are actively harmed by the only alternative available to them. Now consider the economics. The global lighting market was valued at $142.49 billion in 2025. According to Grandview Research, it is projected to reach $225 billion by 2033. This industry sells bulbs, fixtures, smart systems, wiring, infrastructure. All of it requires one thing: a connection to the electrical grid. If you are connected, you are a customer. If you are not connected, you are invisible. You cannot buy a $60 smart bulb if you have no outlet. You cannot install recessed lighting if you have no wiring. You cannot subscribe to an electricity plan if the nearest transformer is 40 miles away. 730 million people exist outside this market entirely. The industry does not serve them, not necessarily because it refuses to, but because the business model does not accommodate them. There is no recurring revenue from someone who has no meter, but kerosene accommodates them perfectly. Because kerosene runs out, you buy it Monday, you burn it by Friday, you buy more on Saturday. It is the ultimate subscription model. A subscription that the world's poorest families never agreed to and cannot cancel. Now, what happens when a device arrives that eliminates that subscription? Salt is effectively free. Water is effectively free. A magnesium strip costs less than $1 and lasts 6 months. There is no refill. There is no middleman. There is no meter. There is no bill. A saltwater lamp is not a product. It is an exit. An exit from a system that profits, not from providing light, but from keeping people dependent on fuel. Now here is how to build one. Because this part is what matters. Materials: a magnesium rod, sold in camping stores as a fire-starting rod for under $2. A carbon rod. You can extract one from any cheap zinc-carbon battery, the type you buy in a pack of 4 for $1. A white LED. A pack of 10 costs $1 online. 2 alligator clip wires. Available at any hardware store for about $1. 2 tablespoons of table salt. 1 glass of water, a jar or plastic container. Step 1. Dissolve the salt in the water completely. Stir until the solution is clear. Step 2. Clip one wire to the magnesium rod and the other to the carbon rod. Step 3. Connect the free ends to the LED. The longer leg of the LED connects to the magnesium wire, that is, the positive terminal. The shorter leg connects to the carbon wire, that is, the negative terminal. Step 4. Lower both rods into the salt water inside the jar. Make sure they do not touch each other. If they touch, the circuit shorts and no light is produced. The LED turns on. No plug, no battery. No panel, no generator. Salt, water, 2 rods, light. If the light is dim, connect 2 or 3 cells in series. Each cell adds approximately 1.5 volts. 3 cells give you 4.5 volts, more than enough to run a bright white LED at full output. You can mount cells side by side in a plastic tray or a length of PVC pipe cut in half. The magnesium rod will dissolve slowly over weeks of use. This is the reaction working. When it becomes too thin, you swap it for a new one. The carbon rod does not degrade. It will last indefinitely. The LED will last for years. The only recurring consumable is the magnesium. For context, a standard magnesium fire-starting rod from any camping supply store contains enough material for weeks of nightly 80-hour use. A 5-pack costs roughly $6 online. That is $6 for months of clean, silent, smokeless light. Compare that to the average kerosene expense for an off-grid African household, $80 to $100 per year. For light that produces cancer, burns homes, poisons children, and emits black carbon at a rate thousands of times higher than a diesel engine. $6 versus $100. Clean light versus toxic smoke. Indefinite technology versus a weekly refill. The math is not complicated. The chemistry is not complicated. The materials are not complicated. What is complicated is getting this information past a system that has no financial incentive to spread it. Magnesium is the 8th most abundant element in the Earth's crust. Salt is in every ocean, every mine, every kitchen. Water falls from the sky. Carbon sits in the remains of every fire, every pencil, every dead battery. The raw materials for light have been sitting on this planet for billions of years. What has been missing is not innovation. It is not technology. It is not research. What has been missing is a simple sentence. You do not need to buy your light. You can make it. From salt, from water, from a $2 piece of metal. Tonight, Aisa Mijeno said that sentence in 2015. Alessandro Volta demonstrated it in 1800. Some unknown craftsman in the Parthian Empire may have discovered it 2,000 years ago. And the only reason 730 million people will burn kerosene again tonight is that there is no profit in telling them they do not have to. This video just told them, if this information was useful, share it with someone who needs it, not someone who wants it, someone who needs it. Because somewhere right now, a family is spending their last dollar on a bottle of kerosene, and the answer is sitting in their kitchen, in a jar of salt water.